Hey guys, welcome to another video. This video is going to be on evaporation and water changes. Keep in mind that what we're trying to do is a little more science. Our view is that most people that do aquarium, planted tank videos aren't scientists. I'm not either. So we're trying to explain these things the best we can using science, but also letting you know if you want real science, go to a scientist. So a lot of this stuff is experiential based. And when you watch a lot of videos online, a lot of those guys have tons of experience, but aren't very good about transmitting information. So the first thing is, what is evaporation? Evaporation is simply molecules inside the water trying to equalize with molecules in the air. So the surface, amount of surface area of the water is going to dramatically affect your evaporation. But there's tons of other factors, one of those being temperature, one of those being basically humidity, basically how much of the water molecules that are trying to come out of the water are already in the air. That's humidity. So if the air is saturated with those water molecules, you're going to get less evaporation. All you need to know is that the molecules of water are trying to get out. They're always going to get out, but they're going to go faster based on different variables, one of those being warmth. So basically, if you have a heater in your tank and your tank's running at 82 degrees and its ambient temperature outside is 74, that differential and the speed of the molecules in the 82 degree water, which is pretty warm, are going to cause that water to come out pretty rapidly. So what's going to happen is a 15-gallon tank, this is our tank right here with the fish in it. What's going to happen is that 15 gallons is going to become 13 gallons pretty fast. What we're going to do, what we're going to try to do in this episode efficiently is to draw a parallel between what happens here and what happens in nature. Because as always, we think that's kind of how you're going to learn what needs to happen here. But you can also take into account the differences between enclosed, smaller water spaces and of course larger ones like lakes. What we're trying to do first is show you in a tank what's going on with this evaporation and how this affects fish and plankton. A lot of this depends on how old your tank is, which we're going to try to get to probably in another video. But the life of a tank or of a lake or a pond dramatically affects how things happen. These things are always more complex, and that's why a professional scientist would probably answer these things better, but you don't have them sitting in your living room and they don't make videos like this. I, for one, again, am not a professional scientist. I'm a professional philosopher. Makes you wonder what I'm doing here. But part of philosophy is learning to learn. When you have a 15-gallon tank, the water's warm, it evaporates overnight, and you come in and the water's here. What's happened is this amount of water, in this case 2 gallons, has gone into the air and created humidity. So what that's done is it's taken 2 gallons of H2O, pure water, out of your tank. But for the most part, it's only H2O, which means however much TDS, I'm gonna explain that in a minute, was in this section, in these 2 gallons, is now in the 13 gallons, increasing the density. A tank is H2O, pure water, plus TDS. I'm sure we've made up this way of explaining it, but TDS is total dissolved solids, which means everything in the tank that's a solid, that's not water. That's all you need to know. There's all kinds of things in water, including all the nutrients for plants, all the contaminants, pollutants from wherever you got your water from, salts, dirt, particles of things. TDS can be used to tell you totally what's in the tank other than water. So when these 2 gallons go out, the H2O goes out, but the TDS stays in. Whatever is your TDS, whatever is the dissolved solids in your tank, that 2 gallons worth of those has now gone down here and increased the percentage of TDS, the parts per million, the density of that TDS in the remaining water, the 13 gallons. And that's why you have problems. That's why people top off their tank. In a perfect world, every time that water went down, it would get topped off. What you have to remember is topping off water has to be similar to the water that left, if not exact. When we're saying pure water goes out, pure water needs to go in. 2 gallons of pure water needs to be added to keep this tank in a balance. Ideally, in a perfect world, it happens nonstop, which means as it's going down, it's going up. And that's where you would have to have some real technology where you measure kind of a small increment decline of the water volume and having new water put in. But it needs to be RO or whatever version of pure water you have. Because if you just pour in the same water that you used or any water with TDS in it, you're going to increase the TDS again overall in your tank. And because plant tanks are so weird, you have to be worried about where that TDS is coming from, what it is. And you're not going to measure that with a TDS meter. So using RO, using pure water, knowing what your total dissolved solids are by only adding to RO water is extremely helpful. So here I'd like to go to our example in nature. When you look at a pond or a lake, what normally you have is water coming in, which is called a watershed. You have the level of the lake, and then you have water out, which is usually a river or a stream. The example I use is Lake of the Ozarks in Missouri, where I grew up. I probably ruined it, so don't go there now. That's the Osage River dammed up. So the Lake of the Ozarks, the largest body of water in the United States, measured by shoreline square miles. At least that's what I read. 3 small tributaries are also dammed up through the course of the Lake of the Ozarks. It's huge, take my word for it. And an interesting point is a city named Lynn Creek, which was the county seat for that county. When they flooded by damming up the Osage River and creating the Lake of the Ozarks, they flooded the city on purpose. Don't ask me why. And there was a huge complaint about it. All the buildings went underwater and they had to build a new city to become the new county seat. That's kind of what happens when you dam things up. That created a lake. That lake has an in and out. Your tank does not have an in and out. So how do lakes deal with this? Because they have some evaporation, but they also have water coming out. In this case, the Osage River goes in. That's the watershed, along with all kinds of drainages and these other tributaries. And then water goes out, which is the continuation of the Osage River. So what we have here is a natural water change system. There's evaporation, but there's also a huge amount of water going out, more water coming in. That body of water is constantly changing. Now it's going to stay similar, but what it's doing is naturally equalizing in a way that promotes life and ultimately balance, which is really what you're looking for in a plant tank. So in an aquarium, you don't have an out. You have an in, which is you pouring water in. You have the out of the evaporation, but you don't have a large source coming out and a large source coming in naturally. So you're creating all of this. So you're creating the water coming in by pouring it in there. You're topping off with pure water. But a water change is basically taking the place of the watershed and the continuation of the river. You're going to actually take water out manually. You're going to put water in. I know this is really simple, but that's your water change. So what your water change needs to do is be the same water as the water in here, if you're topping off correctly. To maintain the TDS, whatever it is, we're going to talk about that in the TDS video in terms of just maintaining a stable TDS. To maintain that, you want to put the same water in that you've always put in, the same water out, and a simple $10 TDS meter is going to give you a guideline for that. So in a 15-gallon tank, if you do a 20% water change, that's 3 gallons. First of all, clean the tank in total before you do the water change because it makes particles float and you pull more of them out. But then once you have it down, you can clean the glass easier, and then you take that same water that you always use, which in this case, I'm recommending RO plus, that's supposed to say conditioner. Same conditioner you always use. Just basically think of it as prepared water, which is similar to the water going out, but that water going out is going to have more contaminants in it. It's going to have any byproducts of the life in the tank, and some of those are bad, ammonia, for example. So you're pouring in the 3 gallons of pure plus conditioner. Another thing I want to say at this point, because this is kind of enough for now about evaporation and water changes, none of this stuff is precise. No one knows all the answers. And unfortunately what happens is when you do water changes, things look better. And I don't think people know all of the answers for why that happens. I believe some of it is the genetics of the animals, the plants and the fish. Those genetics, especially for certain forms of life, are built for change. So when that change happens, they react positively. Discus, for instance, come from lakes that have constant rain. And what that rain does is add outside water to the body of water constantly, which constantly causes it to change, flux, move out. That flux is not necessarily different water, but it's flushing contaminants, adding pure water from the rain. It's constantly, it has to happen over a long period of time, but it will constantly reach an equilibrium in change. And so that change is good for discus. So I think some plants and fish like that, and that's not something everyone can measure unless you spend your life studying Acara cichlids and know through your genetic studies that they appreciate change. So again, some of this is not precise. I like to call it magic. But the truth is, when you do water changes, especially if you do them consistently, especially if you do them the way I explained it, what happens is the fish get hungrier. So the reason they're hungrier is their metabolism is able to go after food more than it is to defend itself from weakness, disease. The reason fish ever get sick, except for old age, is when parameters have gotten out of whack. Your immune system goes down, and it's a response to that immune system. The body's systems put energy into the immune function rather than to things like growing, eating, trying to maintain health that they shouldn't have to maintain if they were happy. So you do the water change, then they want to eat everything. They also get more colorful. Same thing's true for plants. I'm going to wrap this up. Let us know in the comments which things we glossed over, because there were a lot. Watch out for the TDS, the substrate, the CO2 videos in the future. to kind of work in collaboration with this. Let us know if you have any questions, and thanks for watching.